Just leave like a little space because we're going to generalize. So all I'm asking you to do here is go ahead and copy this down. You don't need tons of space. Okay? And then we're going to fill it in together. All right, so the first column represents the equations that we're going to talk about. The second column, what do you think parent fn means? Parent function. That fn means parent function, so we're going to talk about what parent function it's part of. Then we're going to draw a very rough sketch. We're not drawing exactly what these graphs look like. We're just drawing a sketch of what they could possibly look like. Okay? We're going to learn what a degree is, and we're going to talk about the max number of turns for each one. Okay? So, let's start off with one we know real well. What's that first one? Linear. Y equals x is a linear function. What's the sketch of a linear function look like? Yeah, just a line. We're going to skip the degree for just a moment and come back to it. So let's go down to y equals x squared. What's that parent function? Quadratic. What does that graph look like? A parabola. We spent a lot of time talking about quadratics. They could open down, they could open up, they could be skinny, they could be wide. We've got lots of things that can change, right? Now I'm going to go ahead and tell you that the degree of a quadratic function is 2. Where do you think I got that number? No, don't overthink it. Squared, yeah, this squared right here. This exponent right here. Your degree is the highest exponent. So what do you think the degree of a linear function is? 1. What I mean by max number of turns, I mean how many times does the graph change directions? How many times can the graph change direction? So look at a quadratic. Yeah, we go down, and then right about this point, we're going to change and go the other direction. So how many times, though, do I change? I just change once. I have 2 different directions, but I only change once. So the max number of turns I have is 1. What's the max number of turns in a linear function? 0. I'm not allowed to change directions in a linear function, or else it's not a linear function anymore. All right, let's try y equals x cubed. What's that a part of? Cubic. Sketch in the air. Remember what a cubic parent function looks like? That was cube root. So this one's straight. It's more up and down, right? It's a taller S. What's the degree of a cubic function? 3. And what's the max number of turns, you think? 2. Right here and right here. That's when the graph changes direction. Anyone know what we call y equals x to the fourth? Does start with a Q. Quartic. What's the degree of a quartic? 4. How many turns do you think it's going to have? 3. So I'm going to, what I'm about to draw is not the quartic parent function, okay? You can graph y equals x to the fourth. It's going to look incredibly similar to y equals x squared, okay? I'm just going to graph a possible quartic function, okay? So I don't want you to think that this is the parent function. It's just a possible one. So I've got to have 3 turns. So I'm just going to start somewhere. There's 1 turn, 2 turns, 3 turns. But this doesn't mean this is what every quartic looks like. It could be facing up. It could be super, super stretched out. It could be super, super skinny, okay?
Could one be like really stretched out and could get like smaller?
Yeah. They could look totally different. What we are doing, though, is just generalizing how many turns can it possibly have. Okay? All right. X to the fifth is very creatively named a 5th degree polynomial.
Wow. Yeah, what happened to the...
I don't know. What do you think the degree is? 5. How many turns can it have? 4. Take a second, try and sketch what you think a graph might look like of a 5th degree polynomial. When you've got your sketch, share it with someone next to you and see if theirs looks similar. All right, so how many turns do we have to have? 4 turns. So you might have started up or down. Doesn't matter. I'm going to make 1 turn, 2 turns, 3 turns, 4 turns. Yours might look a little different, but what should be true about those arrows? They're going in opposite directions, right? All right, so let's generalize this. X to the nth. What would I call this? An nth degree polynomial. What would its degree be? N. And how many turns could it have? We have no idea what this graph could possibly look like. I can't even try and sketch it. Okay? How can you kind of generalize a rule for when the arrows are going to be pointing in the same direction, when they're going to be pointing in opposite directions? Adam? Yeah. For even degrees, notice in each of my green ones, my arrows are pointing in the same direction. Okay, what about when it's an odd degree? 1, 3, or 5? They're going in opposite directions. Okay, so let's generalize that. When you're talking about what happens at the ends, or the arrows, you're talking about the end behavior of a graph. Okay, you talk about the tails. That's kind of what we call those ends. Okay, so we're talking about the end behavior. So when we have an even degree, is the end behavior for the right and the left the same or different? Same. When I have an even degree, the end behavior is the same on the right and left. even degree means we have the same right and left end behavior. Why do you think I gave you this hint, like parabolas? Yeah, because parabolas, do they have the same end behavior? Both tails are either pointing up or they're pointing down, but they're always pointing in the same direction. Okay? So if you don't remember necessarily this rule, just remember the even degrees, the end behaviors are all going to be the same. So they're always going to be either both pointing up or both pointing down. Odd degree is opposite end behavior. And here I gave you the hints of think about a linear function or a cubic function. You're never going to be able to graph those functions where the arrows point in the same direction. They must be pointing in opposite directions. So I want you to box or circle or something in even degree, the word same. In an odd degree, the word opposite. Those are going to be our keywords. Even is same, odd is opposite. All right, well, that tells us what the right and the left do in relation to each other, but then we have to decide, are they going to be facing up or down? So, in order to tell that, we're going to look at the leading coefficient of a polynomial. The leading coefficient of a polynomial is the coefficient of the highest powered variable, the highest degree variable. The leading coefficient is the coefficient of the highest degree variable. So it's whatever that first number is when you write it in the correct order, from highest power to lowest power. I'm going to abbreviate LC for leading coefficient sometimes. So if you ever see that, that's just me saying, okay, this is what I mean, the leading coefficient. All right, I'm going to let A represent my leading coefficient. When my leading coefficient is positive, when my leading coefficient is greater than 0, okay, that means I'm going to rise right. What that means is that as my x's get really, really big, my y's are also going to get really, really big. So as you look to the right of the graph, the arrow on the right-hand side is pointing up. Okay? So I don't have any idea what the rest of the graph looks like. No clue. I just know somewhere on the right side, it's pointing up. Could do anything it wants over here. But A greater than 0 tells me that as you go really, really, really big to the right, you've going to have to look up to get your arrow. So what do you think it's going to mean when A is less than 0? It's going to fall right. It's going to fall right. No, not the same. So something is happening. We don't know what, but it's going to fall to the right. So think about parabolas with this. Okay? When we had a positive number in front of x squared, which way did our parabola open? Up. So it rose to the right. Also rose to the left, but that's because of the degree being even. Okay? When we had a negative number in front of the x squared, which way did it open? Down. So it fell to the right. Okay? So in order to figure out what happens on the left side, First, we're going to figure out what happens on the right side, and then we're going to decide even or odd. If it's even, the left side is going to be the same. If it's odd, the left side is going to be opposite. Okay? So, I like steps when I'm attempting a problem. I like to have steps to work through. Okay? So, if you are trying to sketch a graph of a polynomial, all right, first you need to use your leading coefficient to get the right end behavior. So you're going to decide using your leading coefficient, does it rise right or does it fall right? Then, once you know your leading coefficient, if you know if it rises right or falls right, then you have to decide, okay, is it an even degree or an odd degree? So is it going to rise left or fall left? Is it going to do the same or opposite? Yes? It's the number in front of x that has the highest degree. So like if I had 5x squared plus 3x plus 2, my leading coefficient would be 5. Okay? We're going to do some practice with it and finding our leading coefficient. No. Yeah, the leading coefficient is always this number before like x to the 6th plus 3x to the squared plus 2. It's whatever this number is right here. Okay? All right. Yep. All right, so we are going to practice doing some analyzing of these equations and deciding how to graph it. Okay? Now, we know how to find the vertex of 4x squared plus 3x minus 1, get the x-intercepts, and graph it exactly. But I don't want to graph it exactly. I just want to sketch using these new rules. Okay? First thing you want to check is this in standard form? Is it from the highest power to the lowest power? Yes. Then I would suggest circle your first term. Circle your first term. That's what I'm going to call your leading term. That's okay. Thank you. So what is the degree of this polynomial? Remember, degree is your highest exponent. 2. So this number right here. The maximum number of terms then is going to be 1. All right, now let's figure out our end behavior. In order to decide if it rises right or falls right, which number am I looking at? 4. I'm looking at the leading coefficient, and the leading coefficient here is 4. Is 4 greater than 0 or less than 0? Greater than 0. So do I rise right or fall right? Rise right. To decide what happens on the left, I look at even degree or odd degree. Is my degree even or odd? Even. So am I going to be same or opposite? Same. So what am I going to do on the left? Rise left. We already knew that though, right? This was a positive x squared, so we knew this parabola would open up, which it does. Rise right, rise left. Okay? All right, here we go. Y equals negative 5x squared plus x cubed plus 3. What problem do you notice with that? Good, it's not in standard form. So that's a red flag, and you should automatically rewrite it. How would I put this in standard form? Good. What's my leading term? This first one, this x cubed. See how easy it would be to forget and make negative 5x squared your leading term? Got to make sure it's in standard form. All right, degree? 3. Max number of turns?
2.
All right, end behavior. First, I'm going to find out my right end behavior. So I'm going to look at my leading coefficient. What's my leading coefficient? 1. Think of there being a 1 right here. Is 1 greater than 0 or less than 0? Greater, rise right or fall right? Very good. What do I look at to decide the left? Yeah, the degree. Is my degree even or odd? So odd is same or odd is opposite? So what's going to happen on the left? Fall left. So let's do some sketching here. On the left, I'm falling. I need 2 turns. 1, 2, and I'm rising to the right. Now, if you type this into your calculator, is this the graph that you would see? No. Wait until we finish notes, okay? This is not the graph you would see, but this is a possible graph. All right, another one. Y equals negative 3x to the 4th minus 1. Is this in standard form? Yes? Yes. Go ahead and circle your leading term. It's the only one we care about right now. What's the degree? 4. Max number of turns? What number do I look at to decide if it rises or falls to the right? Negative 3 is my leading coefficient. Good. Greater than 0 or less than 0? Less than 0. So what's going to happen on the right? Fall right. How do I decide about the left? The degree. Is my degree even or odd? Even, because I'm looking at this degree right here. Even means same. So I'm going to fall left. So, fall left, 3 turns. 1, 2, 3. Okay? If I added in, say, x cubed here, if I had negative 3x to the 4th minus 1 plus x cubed, does anything about what I just did change? No. Give me an example of something that would change it. Yeah, if I added x to the 5th or x to the 7th, something like that. Emma?
Well, I guess it wouldn't really work if you had 2 of the same exponents.
Right. Okay, would you try this next one on your own, please? All right, Rhett, what's the degree of this polynomial? Good. Catherine, what's the maximum number of turns? 4. Ivan, what's going to happen on the right? Fall. Good. How'd you know that?
Because
Negative 1 would be our leading coefficient. It's less than 0. And Ryan, what's going to happen on the left?
It's going to rise.
Rise. Good. How'd you know?
Because negative 1 is the leading coefficient.
That's how we know about the right.
It's the opposite of the left.
Good. It's the opposite because of our odd degree. Good. So fall right, rise left, starting pointing up, and I need 4 turns. 1, 2, 3, 4. Okay? All right, so we're going to touch on one last thing today. We've been using this notation, rise right, fall left, those words, okay? And that's great. But there's a little bit different way to say the exact same thing. That's going to be this new notation, which is limits, okay? Limits are going to be a really big idea in calculus, all right? So we're just introducing them super basic here, just so you start seeing them, all right? What a limit means is what happens as you approach something, okay? And in our case, we are going to find the limit as we approach infinity. So we are thinking of this as just another way to talk about the end behavior as x gets really, really, really big, which would be to the right, and as x gets really, really, really small, which would be x to the left. So part of your homework, you're going to use the rise right, fall left, that notation. And part of your homework, you're going to be asked to use limit notation. Yeah?
So for limit notations, like you write this out? Like this, like as...
Yeah, I'm going to show you what this means, and this would be what you would write.
Can we like copy this down?
Huh?
Like, do we need like a space between?
We're going to write like little tiny words under. Just, no, you'll be able to fit it in. You'll be fine.
I already wrote like...
You'll be fine. All right, so as x approaches infinity, or as x goes to infinity, that's what this arrow means, which means am I looking to the right or to the left? To the right, because my x is getting bigger. So as I look to the right, f of x, which is the same as y, f of x is approaching infinity. So is our y values, are they rising or are they falling? They're rising. So this is the limit notation for rise right. Means as you look to the right on your graph, your f of x values are getting bigger. As x approaches infinity, f of x approaches infinity. What about as x approaches infinity, f of x approaches negative infinity? What's happening here? Good. This is fall right. Because this is still right, but now our f of x values are getting smaller, so they're falling. When I talk about x approaching negative infinity, am I talking about the right side or the left? This is the left. And f of x approaches positive infinity. So is that rise or fall? Rise. Good. As x approaches negative infinity, that's still going to the left. But now we are falling. So this is one notation, and this is a limit notation. What questions do you have?
Would you write, like, rise right all along, or would you just write as?
For some of your homework, you're just going to have to say rise right, fall left, or whatever. And then another part of your homework is going to say using limit notation, describe the end behavior.
But
You would just write what's here in black
Okay.
for that answer.
Okay.
Catherine?
So like if you had a rise right, fall left, you'd have to write both of them?
You'd have two limits, yeah. You'd write the one for rise right. As x approaches infinity, f of x approaches positive infinity. And as x approaches negative infinity, f of x approaches negative infinity. Okay? Any other questions over anything we talked about today? Okay, great. Your homework is on page 411 and page 457. Don't forget, you do not need to do number 46 on page 457. I told y'all to cross that out yesterday.